Hello, my name is Alexander Ospina and I am a Senior Cloud Systems Engineer with Logicworks. Today we'll be talking about a topic that we're all familiar with, infrastructure as code, specifically how we can automate our AWS workloads using the latest IaC tools. So anybody that has used a cloud platform in the past knows how simple it is to get started. You provide some basic information, create your account, access that account, and before you know it, you'll have your first cloud resource up and ready to serve content. For most basic situations, this is sufficient. However, when the complexity of our environment starts to rise and when the component list of our environment starts to rise, when there are compliancy needs, security needs, the need to tear down and rebuild the environment at a moment's notice, when these things become necessary, it's no longer feasible to continue to build our resources manually. We must be able to automate this, and doing this in any other fashion becomes a tedious, time-consuming, and far too prone to human error. Luckily for us, IaC is a perfect solution to the problem described. So let's imagine that we are in a scenario where we are a part of a business that has multiple organizational units. There's a prod team, a dev team, a QA team. All of these respective teams look to you to provide them with their AWS infrastructure needs that they use for whatever their purposes may be. Let's say the QA team comes to you and says, we're testing a new feature out on the application and we need a new environment built out ASAP. Everyone needs everything as soon as possible, and it's your job to build this out, turn it over to them. Then they do their thing, install the application, test it, test the new feature, and then afterwards tear it all down. Now, IaC in this scenario, without a doubt, is a must. We cannot continuously build out the same thing manually over and over again. However, what if we are completely able to offload the deployment process off of our shoulders, provide an easy-to-follow console-based solution to our end users, and at the same time protect the integrity of our back-end CloudFormation templates? That's possible today using a combination of IaC tooling along with a service called Service Catalog. So you hear this and you're all in. You love the idea of offloading this work from your team and you're ready to move forward with this plan. The next steps revolve around coming up with a plan of action. Your plan of action involves 3 steps. Number 1, make a decision on your IaC tool. The market is filled with a plethora of tools that cater to different needs based on your team. If your team is more comfortable with a particular language, whether that be Python, Ruby, or Go, there are tools that are based on those languages. If you're not sure about staying on a particular platform, then you may be interested in using a tool that is native to that service. These are all things that will factor into the decision that you make. It will be your responsibility to understand the pros and cons of each tool before making a decision. Number 2, you want to integrate your tool with AWS Service Catalog. Notice how we don't specifically mention CloudFormation. That's because AWS does not pigeonhole you into using their native tool when integrating with Service Catalog. As a matter of fact, if you perform some light research, you'll be able to find an in-depth, comprehensive white paper written by AWS themselves that goes over the integration of Terraform with Service Catalog. Last step states that you want to implement the security features of IaC. This is twofold. On one hand, you want to ensure that your templates are making use of the platform's infrastructural security. For instance, using security groups and NACLs within your CloudFormation templates, also integrating services that are meant to protect the infrastructure like AWS Shield and AWS WAF. If you have an IDS service, then that's something that you also want to make sure that you use within your templates. Secondly, you want to make sure that you're using best practices when it comes to IAM usage on Service Catalog. Practice least privileges on all IAM users when delegating who can build what on Service Catalog. So let's go over some of the more popular tools that are out in the market today. AWS CloudFormation is the one we're all most familiar with. It's been around the longest and has one of the largest communities around. However, if you're unsure about staying on the AWS platform, then this is something that will factor into your decision. As any attempt to move on to another platform will require you to learn a new tool since this is AWS specific. Terraform is an interesting one as well. It's gaining a lot of traction and popularity, and it's also cloud agnostic. What this means is that you can use it across platforms without the need of learning a new tool or new syntax. Sparkle Formation is probably something that many of you have not heard about. It's like Terraform in the sense that it talks to the backend API to generate the templates that's native to the platform. So if you're connected to AWS, it will generate CloudFormation. It also integrates very easily with CI/CD pipelines, which is an essential part of any deployment process. For the sake of our scenario, let's say that you've done your research and you've decided to go with CloudFormation. Now, with any tool, whether it's CloudFormation or something else, it's important to understand the basics of that tool before we start going into the nuances and advanced features. CloudFormation is no different in the sense that it does much of the same things that any other tool can do on a basic level. What you can do doesn't change, but how it does it is what does change. Without a CloudFormation template, within a CloudFormation template, you declare your resources within a block. What's really cool is that when you start integrating this with Service Catalog, you can parameterize your variables within the template to ensure that your end users are only selecting from a specific drop-down menu, for instance. If you want your users to be limited to only deploying instances that are M5 large, M5X large, and M5 2X large, and nothing else, then you can parameterize that within your template, and your end users will only have those options when they attempt to select a size. This is a great way to ensure that you are staying on top of costs. It's important to understand the evolution of IaC. In stage 1, IaC tools were meant to be a one-off solution that was a quick way to script an environment. Later iterations turned this into an essential part of any deployment process, and that really starts off with the use of nested templates. Nested templates are nothing new. They've been around for a long time, but when integrating this with Service Catalog, we really get to use them to their full extent to create a more intricate solution. The idea here is to have your parent template live in version control, whether it's Git or Bitbucket or another kind of software. It will also most likely live in a completely separate AWS account. Now, the idea here is you nest off of this and create dedicated templates that can be used by either specific teams or for specific resources. In this type of scenario, the dev team can have their own template, while resources like auto-scaling groups can also have their own templates. Security groups, VPCs. We've now created a layered architecture that protects the parent template and also allows the nested template to be easily changed. So we've gone over our IaC tools that we have available to us, and now it's time to talk about Service Catalog. So Service Catalog is broken into essentially 3 teams. Your catalog administrators, who in our scenario would be you, would be responsible for managing the catalog of products, organizing products into portfolios, and managing access via IAM. And the way that Service Catalog works is that you have portfolios, catalogs, and products. You can think of portfolios as being synonymous in our scenario to the actual teams. You can have a portfolio for your dev team, a QA team, prod team, and so forth. Within this, you have catalogs of what they'll be able to actually deploy. For instance, QA gets their own instance template. The dev team would also get their own version of the instance template depending on what it is that they need to be able to deploy. They would get RDS templates, ASG templates, and so forth. Your product administrators will delegate the permissions, and your end users will actually deploy the products within the portfolios. Now, one thing that's important to note in Service Catalog is its inherent ability to provide versioning. So let's say QA tells you that they need to be able to use a 4th instance type within the template that you've provided. So you make these changes and make them live and turn over the template to the team. However, when they begin deploying it, they start noticing issues. For whatever reason, the instance type isn't playing well with the metadata of the application, and bootstrapping issues are now occurring, and you are told that you need to immediately roll back. Luckily, Service Catalog saves previous versions of products, and you can roll back with a click of the mouse, which makes these scenarios significantly easier to fix. So let's circle back to our security basics of IaC, who has access to build a product in Service Catalog. That's all dependent on your IAM users that you declare through policies within the console. Who has access to the created resources are also dependent upon the IAM rules and the IAM policies that you associate with the users. And it's important to understand that the practice of least privileges should always be monitored and administered when creating these particular policies. So why IaC? We have a controlled, standardized build process which allows us to ensure that we are on top of costs, we are on top of who is building what within the actual catalog and within the actual portfolios. We have controlled, standardized update process. We are the ones that are in control of who is or what changes are being made to the template and what is actually being published live to our clients. Business units can launch their own pre-approved templates quickly. If there's a situation where they need something to be stood up immediately, you no longer have to be a bottleneck within that particular scenario. There's less human intervention within the environment. This is an absolute big deal here, as we're able to limit the amount of human error that happens within the environment. Consistency across accounts and environments. Through version control, we're able to ensure that we have the final say in terms of what is actually being deployed, if that's how we decide to administer Service Catalog. And for anybody that's dealing with any sort of security issues or any sort of auditing, this is, if there's a way that we're able to make the auditors' lives a little easier, in the end that means that our lives become easier as well. Anybody who's dealt with any sort of security compliancy needs knows that this is definitely a big deal. Logicworks is a premier AWS consulting partner. We specialize in complex, highly regulated workloads for healthcare and financial services and SaaS. If you want help deciding between IaC tools, migrating to the cloud, building a service catalog for your team, please reach out to the team at Logicworks.